This is what the inside of an escalator looks like, the kind you often see in subways, malls, and other public places. It finally clears up a question I've had for years. Turns out it's such a complex and massive system. I have to say, this is a genius invention. All you need to do is stand on it without doing anything, and it carries you up or down. It saves both effort and time. But how exactly does it make the steps move? Let's take a look at how it works. An escalator is made up of a series of individual steps. Each step is a separate metal structure with an anti-slip surface and yellow warning lines. At the bottom of each step are two sets of wheels. The front wheels are fixed to the drive chain by pins, while the rear wheels slide along the inner track. The entire drive chain runs in a continuous loop. So how do the steps turn into a staircase on the slope, then flatten out at the top and bottom? The secret lies in the different tracks the wheels follow. The front wheels, connected to the drive chain, run on the upper track, while the rear wheels are guided along the lower inner track. As the escalator ascends, the lower track gradually narrows, causing the steps to tilt into stair form. At the top, the tracks separate again, and the steps flatten out into a platform, making it easy for passengers to get on and off. The same principle works in reverse when the escalator descends. At the endpoints, the steps flip over and form a closed loop that keeps cycling endlessly. But how does the escalator pull such a massive load? The answer lies just beneath the top of the system. A giant electric motor runs nonstop day and night. At the top is a main shaft, where the motor uses a gear set to reduce speed, then drives two large gears that pull the drive chain. The handrail is powered by a separate shaft and gear system. It connects to the main shaft with a smaller chain, ensuring it moves in sync with the steps. The handrail is usually made of rubber, wrapped around a pulley track. All these components are assembled within a huge reinforced steel frame called a truss, so the escalator can support hundreds of passengers at once. Since it's designed for people to use, safety is the top priority. At the entry and exit points of an escalator, there are comb plates. These mesh precisely with the steps, so any foreign objects get pushed out instead of getting stuck in the step gaps. On both sides of the steps are safety brushes to prevent shoelaces or clothing from being caught at the edges. This simple design greatly increases safety. To prevent hazards from motor failures or broken drive chains, which could cause overspeed or even reverse movement, escalators are equipped with a two-stage braking system, featuring both mechanical pause and brake pads. Even if the power cuts out, the system automatically slows down and stops during overspeed or reverse movement, protecting passengers from injury. In addition, there are safety devices for handrail belt breakage, step collapse, overspeed, and chain breakage, all working together to keep passengers safe from every angle. So an escalator is actually a massive and complex system with tens of thousands of parts working in sync. Installing one can cost anywhere from hundreds of thousands to over $1 million. But no matter how many safety measures are built in, there's always a risk. That's why when riding, you should always check your shoelaces and clothes carefully and never jump or play on it. If an emergency happens, press the red emergency stop button on the escalator right away.